So we want to solve this equation. Now we've got a quantity squared equaling a negative number. So right away, do you see that we're going to have imaginary results here? Let's just think about this. You know, what we've got over here is that we've got a positive quantity, right? Because we're squaring something equaling a negative quantity. And that just can't happen with real numbers, so we're going to end up with imaginary numbers here. But let's continue on. So because I've got something squared isolated on the left side and a quantity on the right side, let's take square roots of both sides here. So I'll indicate that with the square root of the quantity x plus 4 squared equals the square root of negative 32. And on the left side, we've got the square root of the square. We know that gives us the absolute value of x plus 4 equals, now, as soon as I see a square root of negative, I'm going to take that I out. And then we'll work with that 32. So we're going to have the absolute value of x plus 4 equals I times, now 32 we can write as, I'll go ahead and write it here. Some of this you can probably do in your head. But we're going to get 16 times 2. This will give us x plus 4 equals I times square root of 16, square root of 2. And we can deal with that one, so we'll get absolute value of x plus 4 equals 4I square roots of 2. That 4 coming from here. So right from here, you take the I out, right? Take the I out, and then 32 you write as 16 and 2. Square root of 16 is 4. 2 stays under. 4I square root of 2. Now, let's take absolute value. So when you remove the absolute value sign, this is when you get plus or minus. So we'll get plus or minus 4I square root of 2. And one more step, let's subtract this 4. So that will give us x, let's see if we can write it, x equals negative 4. Let me write that so it's readable. Negative 4 plus or minus 4I square root of 2. Now, this is imaginary, complex, so we could write this I way out here at the right side, so it would be perfectly okay to write this as x equals negative 4 plus or minus 4 square roots of 2I. But often, when you see an I and a radical, you write the I in front of the radical, just so you don't get something confused like this. 2, and then if you write the I right here, now you don't know if it's inside or out. Let's use the square root method to solve this equation. So let's take square roots of each side. So we'll get the square root of 3x minus 1 squared equals square root of 5. Take the square root of the square, that'll give us the absolute value of 3x minus 1 equals square root of 5. And we're not going to be able to simplify that square root of 5. 5's prime, so we're done with that. So let's remove the absolute value signs. 3x minus 1. This is where we get plus or minus square root of 5. Let's add 1. We'll get 3x equals 1 plus or minus square root of 5. And let's divide by 3. Now, I'm going to divide by this 3, and because I have no imaginaries over here, I'm going to divide the entire side by 3. So we'll get x equals 1 plus or minus square root of 5 all over 3. So this is our solution, but let me just make one other comment here. If we had this up here, so if we had this, what if we had 3x equals 1 plus or minus, say, 5I? Now we don't, but just suppose we did. Then when I divide through by this 3, I'm not going to divide the entire side by 3, although some people would say that's okay. But I think what we could do is just divide every single term by 3, giving us this expression here, x equals 1/3 plus or minus 5/3 I. And I like this form, just me, because it's in the form a plus bi, which is the standard form of a complex number.